So today's question is intersection of a linked list. The question problem statement is that you are given two linked lists which intersect at a point, and you need to find the intersection of that linked list and return it. So basically in this example, this is the intersection and you need to return the data of the node where it intersects. Now remember that you just can't compare it with the data. For example, suppose this node was 3 instead of 23, then that doesn't mean that this is the intersection point. Or suppose here also it contains a 3. So basically the node location or the node address should be same. So how will you do it? It is a very simple algorithm that just contains 3 to 4 steps. So let's get started. First of all, we see that the problem is no longer a problem if both the nodes are at the same level or have the same nodes before intersection. In this case, you can simply traverse one by one and check whether the node is same or not. But this makes it complicated because this can have any height, and then if you try to apply the same technique of traversing the node one by one, then it will be at a different position at different time and you will not find this node. So to convert this problem to a problem where it has similar number of nodes, same number of nodes before intersection, we will do just one thing. We will count elements in both nodes, both lists. Okay, so suppose this list contains total of 1, 2, 3, 4 elements. So C1 will be 4. And this contains 1, 2, 3, 4, 5. So C2 will be 5. So the next step will be whatever linked list has a greater number of elements, we will just move to the difference of those elements. For example, the difference is 5 minus 4, that is 1. So basically we need to go to the after the first node, right? So that to ensure that both the linked list have same number of elements before you get the intersection node. Okay, so I'll just try to clear this up and then we can move to the next step. Okay, so we got it right. First step is finding count. Second step is mode elements, list, traverse, difference number of nodes, right? So now after these two steps we are basically here. The first step pointer will be here and the second step pointer will be here, right? Now the third step will be traverse one by one and check if node is same, right? So for one iteration we'll just move our pointer to here. For second iteration it will both point to the same node and then our condition will be satisfied. So we can quickly move to the code and see how it looks. So this is the Geeks for Geeks prompt. You can see that it is asked in so many companies, so it's pretty basic and important question. We are given a linked list and we need to return the data wherever it is matching. So this code, let me show you. I've already written a utility function that returns the number of elements in a node. So you will basically pass the root element, and while it is null, it will keep a counter and return that counter. So this is our main function where we will return the intersection point. So the first step, remember, we just get the counts of both the list. Then if count 1, that is list node head 1's count is greater Then we'll store a difference of C1 minus C2. And here I have created two nodes where I will store which list is having the greater element. So list 1 will have greater element. So we will just appoint head 1 to list 1, and list 2 will be the head 2 that we don't need to travel. And similarly, if this count is greater, like the head 2's count is greater, we'll do list 1 is equal to head 1 and list 2 is equal to head 1, right? Now, the next step, this is the step 2. So here we are simply traversing the list 1. In remember that in list 1 we stored the list in which the number of elements are more. So we will just traverse till this I becomes less than diff, that is we are traversing the difference. So after this point, after this, both lists have same number of elements, right? So now we can do a traversal and check whether the node that we are getting is same or not. So while both the lists are null, we can just do a list of head next, and then we can simply check if this is equal to the same, right? If list 1 becomes list 2, we can simply return any of the list's data. So this is pretty simple. Let's just try to submit it and see if this pass. See, our question has passed.